In this lesson, we are going to practice solving word problems with a system of inequalities, and we're going to do that by going through an example together. Jackson is having a party for his friends on Saturday. Jackson expects at least 7 people to show up. He is trying to figure out the total cost of all of the pizzas. He calls his local pizza place, Meredith's Pizza, who says that the cost of his pizzas will be less than 5 more than 2 times the number of people he needs pizzas for. So, Jackson needs to do a little bit of math to figure out how many people, how much the cost of the pizzas are. But before he can do that, he needs to first establish his variables. So let's first figure out what the variables even are. We know that Jackson expects at least 7 people to show up on Saturday. That means Jackson doesn't know how many people he's going to show up on Saturday. So our first variable we are going to establish is x, and x is the number of people who are going to show up on Saturday. The number of people. Our next variable is going to be what we're solving for. We are trying to solve for the total cost of all pizzas. So why not make that variable y? So y we're going to establish as the cost of all pizzas. The cost of all pizzas. Great. Now we can set up the equations, the systems of inequalities. And so let's walk through that together. We know that Jackson expects at least 7 people to show up on Saturday. And this is going to be our inequality for the variable x. We know if Jackson expects at least 7 people, that means he expects 7 people or more. So when we're writing this system of inequalities, we know that x, the number of people, is going to be greater than or equal to 7. Because 7 people could show up, 8 people could show up, 9 people could show up, 13 people could show up, 26 people could show up. But the minimum number of people who will show up is 7. So it'll be 7 or more. So x is greater than or equal to 7. Our next inequality is going to be the total cost of all pizzas. Meredith on the phone says that the cost of his pizzas will be less than 5 more than 2 times the number of people. So if we write this, we know the cost of his pizzas, which we establish as variable y, will be less than 5 more, so 5 plus 2 times the number of people, which is x. So here we know our second inequality is y is less than 5 plus 2x. Notice Meredith did not say less than or equal to. She simply said less than. So we are just going to use the less than sign. We are going to solve this system of inequalities using graphs. And the first graph we're going to tackle is the one y is greater than or equal to 7. And so I took the liberty of graphing it for you here. We have found the x-intercept here in green, and we notice that this line is solid. It's a solid line because we're seeing here that it's a greater than or equal to, oh, that arrow is not pointing to what I want it to, here. A greater than or equal to sign, so it'll be a solid line. We know that this graph is accurate because we're saying that we can have any x value greater than or equal to 7. So literally any value greater than or equal to 7. There's no condition for a y value. There's no y value in this inequality. And so we can essentially say that any value where x is greater than 7, which is why you see this big blue chunk of potential values that can satisfy this inequality. The next inequality we're going to graph is y is less than 5 plus 2x. Graphing inequalities like that is a little tricky. And the first thing we're going to do is we're going to swap out that inequality sign for an equal sign, and we're going to graph y equals 5 plus 2x. And so I did that here. We have the graph of y is equal to 5 plus 2x, or you can also write y is equal to 2x plus 5 in slope-intercept form. We can see here that we have the y-intercept, we have the x-intercept, and we just have a random point here. But this is the line, y equals 2x plus 5. But this is the line. We are looking for the graph of the inequality. So to do that, we're looking for the graph of the inequality y is less than 2x plus 5, or y is less than 5 plus 2x. And so to do that, we want to figure out which side of this line we want to be shading, because which side of this line is accurate and satisfies the inequality y is less than 2x plus 5. So we're just going to check some points. Let's say we check the point 10, 2. So this point right here, is this point, I'm actually going to do this in a different color, not purple. Let's go back to green. So let's look at 10, 2, which is this point right here. Does this point, this coordinate point, satisfy the inequality y is less than 2x plus 5? And the only way we can check that is to test it. So we're going to plug it in. Y equals 2, so 2 less than 2 times 10, we're plugging in x, 10 for x, plus 5. We know 2 is less than 20 plus 5. 2 is less than 25. Is this true? Is 2 less than 25? It is. That means this is true. That means this point is true. So far we're thinking that we are going to be shading in this bottom portion, but let's check one more point just to double check. We're going to do this next point in red. So let's test the point. Let's test the point -10. -10, 2. We're going to do the same thing we did before. We're going to plug it into our inequality. Y is less than 2x plus 5. And so we're going to say 2 is less than 2 times -10, watch your negative signs, plus 5. So 2 is less than -20 plus 5. 2 is less than -15. Is that true? Is 2 less than -15? No, that is not true. That means this point here is not true. So we can say that this is probably going to be the shaded region of this inequality. And so it is. We shaded in the region of the inequality, and if you notice, we're back to a dotted line, or not back to, but we have a dotted line, because this inequality is not a less than or equal to, it is simply a less than. And because we're solving a system of inequalities, we want to put these two inequalities on top of each other. So here's a graph with both inequalities. Y is greater than or equal to 7 in red, and y is less than 5 plus 2x in blue. And the area that they are intersecting is kind of in purple here, and I'm going to outline it. It's very poorly outlined, sorry. But this is the section here where the two overlap. So this area right here is the solution to your inequality. But one thing to consider, you can't have, I'm going to assume that Jackson's not going to pay negative money and he's not going to have negative people there. And so we can make the assumption that x is greater than 0 and y is greater than 0. So this section in green is actually the section we're looking for. Right here. This is Jackson's sweet spot. Now, unlike a system of linear equations, Jackson won't know for certain what the price of his pizza will be. Why? Because Jackson doesn't know how many of his friends will be coming to his party. He knows at least 7 people will be coming, but he doesn't know how many more than that. While it can feel frustrating for Jackson to not know how much he'll be paying for the pizzas, this is the advantage of a system of inequalities. Especially when solving real-world problems, a system of inequalities is really helpful when we're looking at something in the future. And if we don't have exact numbers, we have a general idea, like Jackson does. So these are the steps that you can use to solve a system of inequalities using word problems.